Triumph over technical difficulties. Okay, so let me go ahead and get the screen share rolling. Folks, if you're just joining us, we are about to start. Let's go into presenter view and then share my screen, let's say. Haha, success. So you are at AWS Graviton with the Elastic CI stack for AWS. I am Nick Rycar, Technical Product Marketing Manager at Buildkite, and I'm joined by
Arthur Petitpierre.
Hey.
Yeah, go.
So yeah, we're gonna start off by giving you all overview. What is Buildkite? What is AWS Graviton? And then we're gonna see how two great tastes can taste great together. But right off the top, if you don't know Buildkite, I don't know how you got here, but I'm glad to see you. We are a platform for running fast, secure, and scalable continuous integration pipelines on your own infrastructure. Our niche is in hybrid SaaS CI/CD, where we try to combine the convenience of a hosted platform, where we host essentially the orchestration layer, the control plane, where you're looking at your dashboards, creating your pipeline, setting up users, but you're able to build and test with the security and flexibility of working behind your firewall, whether that's on-prem in a data center or out in the cloud, somewhere like AWS. Gives you the ability to keep your code on your servers and to make your tests happen in an environment that looks as close to prod as you need it to be. And to take a look at things from the AWS side, I'm going to hand the screen share over to Arthur to give you an overview of AWS Graviton.
Sure. Here we are. Okay, so a little bit about me. I'm Arthur Petitpierre. I'm a specialist SA looking after EC2 and more specifically our Graviton-based instances. I've joined AWS in 2016, so a while now. And my background is in infrastructure, cloud, architecture. I've done lots of high performance computing and been working on EC2 since a little bit more than 5 years now. And I'm based out of Seattle. So talking about Graviton and EC2 in general. So you probably know that AWS among the cloud providers is the one offering the broadest possible choice of processors. We started our cloud journey with Intel-based instances. Intel was definitely the best processor brand available at that time, and it made sense to start with it. We added AMD processors later when they started to be competitive again. And the latest addition to our portfolio are the Graviton processors. So the Graviton processor, you might wonder, well, what are those things? Graviton, is that a brand? I've never heard about it. Well, it's actually the second generation of processors that have been designed directly by AWS. So we have a team that has the capabilities to design processors. It's actually based on an acquisition that we made a while ago. We acquired a company called Annapurna Lab. Actually, we started to work with those guys on a couple of components that we were using on EC2, and they were doing such an amazing job that we figured out that we wanted to get them as part of the company. And since that time, we've been relying on Annapurna Labs to design custom silicon. So they have helped us to build the Nitro platform, which is our new generation virtualization stack. And I'm going to talk about that a little bit later. And the latest of our innovation was to design a general purpose processor. And so the Graviton 2 is such a general purpose processor. It relies on the ARM64 architecture. So it's custom built using the Neoverse N1 design. It's a pretty beefy chip, 30 billion transistors, which starts to be a big one, manufactured using 7 nanometer technology. And one of the interesting things with Graviton 2 is that it's up to 3.5 times more energy efficient than the processors that you would find on our other non-Graviton based instances on AWS. The reason for that and for the good amount of performance that you get with Graviton is that we have designed it with targeting really cloud native workloads. And the reason why we have chosen to develop those processors in-house is because as a cloud provider, we have quite a unique position to understand what our customers are doing on the cloud and how they're utilizing our instances. And that allows us to rapidly innovate, take this feedback and integrate it in the next generation that we release on a regular basis. When it comes to the instances that are using the Graviton processor, so one of the interesting things is that they are 40% better from a price performance compared to our existing x86-based instances. We have, for Graviton, a pretty broad portfolio now. So we are covering our classical M, C, and R classes. So the M6G, the C6G, and the R6G. We also have the C6GN, which is pretty similar to a C6G, so up to 64 cores, but that time with an additional network bandwidth capability. C6G goes up to 25 gigabit per second, whereas you can go up to 100 with C6GN. We also have a T4G, which is a burstable instance, pretty good for all your spiky workloads, still relying on the same Graviton 2 processor. And the latest addition to our portfolio is the X2GD. The X2GD is a high memory instance, actually the one with the best the lowest price to amount of memory, and it has up to 1 terabyte of memory. All those instances are available right now. You can use them today. We have variants with local disks for the M6G, C6G, and R6G family. So you can use them with local NVMe SSD disks with super low latency, high bandwidth. And we also have bare metal options. So versions of those instances where we have removed the hypervisor layer so that you would get full access to the performance counters, or where you could run your own hypervisor layer. In terms of components that we use for those instances, there's obviously the Graviton 2 processor. On the motherboard, we also have a custom chip called the Nitro Security chip, which offers an API that is cryptographically authenticated when you access to all the component where you can change a firmware, for example, or change a configuration. And that one is integrated to the motherboard and protects all the hardware resources. We also use the Nitro cards, which are specific devices that are connected to the PCI Express bus and that we control, and via those devices, we emulate hardware devices on the PCI Express bus. So when you see a network interface on a Graviton 2 based instance, or actually any of our Nitro based instances, that network device is actually a piece of hardware that is emulated by one of those dongles. We do the same for our EBS volume that are emulated as NVMe disks. And we also use those dongles to do the monitoring and manage the security access to those instances. For those of you who are familiar with AWS, the security groups, for example, are implemented at that level. And one of the cool things with that is that at the hypervisor layer, we no longer have to manage a software device model. All the devices or implemented in the hardware using the Nitro cards. So we can directly build a pass-through between the virtual machines and those devices through our hypervisor, and you get bare metal-like performance on those VMs. In terms of TCO with Graviton-based instances, they are the highest performance in their instance families. They are 20% lower cost based on the on-demand price. And overall, when you cumulate the performance and the lower cost, we consider that they are 40% better from price performance standpoint compared to our other x86-based instances. If you're willing to adopt Graviton-based instances, there's one piece of documentation that I really recommend having a look to, which is our Getting Started guide on GitHub. We've assembled it with all the feedback that we got from the thousands of customers that we have migrated to Graviton. It's really designed to help you as a developer or as a deployment engineer, or if you're building applications, you will find all the information that you need to choose the right compilation option, know what are the libraries with which you will get the best performance, know the versions of operating systems that are available, that kind of stuff. In general, one piece of recommendation, use the latest possible version of either operating system, compilers, or language runtime when you run on top of Graviton 2-based instances. Those processors are still pretty new, so there's lots of improvement that are brought to open source projects or even proprietary software. So using the latest version will give you the best level of performance and the latest feature. Thanks a lot, and I'm going to go back to you, Nick.
Thank you, Arthur. So I'm going to go ahead and share out my screen. And as I'm getting set up here, a reminder for folks that there is a Q&A widget in the app if you'd like to ask us any questions. And I threw a link to that Getting Started guide in the chat for folks. I wanted to take things back to the sort of hybrid CI model that I brought up at the head. And the one sort of elephant in the room when we talk about that is that there is still the matter of managing the infrastructure for your builds. Being able to build in your own environments has a ton of security and efficiency benefits, but then you have the overhead of managing the infrastructure. The beauty of using a system like AWS is that you get to mitigate the cost of that management via a shared responsibility model, where your cloud vendor is responsible for, and I always love this framing, the security of the cloud. We have to, make sure that the data center is locked down and that you have the granular permissions that you need to lock your stuff down. But then it is your responsibility to lock that stuff down. I can make an encrypted S3 bucket that's private to the world, but I have to put those settings in place. So one of the ways that we can sort of make the cost of that ownership even easier is by automating how we deploy our infrastructure. So in AWS, there is CloudFormation, which essentially lets us define our virtual data center in a file, where everything from the network config down to the individual instances, storage, et cetera, is defined. And at Buildkite, we produce a CloudFormation template that is called the Elastic CI Stack for AWS. So the idea is to give you a prescriptive environment for running your builds, where you can have it take advantage of all of the things that the cloud brings to us, being able to really fine tune the efficiency of what you're running, both from a compute and cost perspective, and spin up capacity when you need it and spin it down when you don't. The nice thing here is that there are a lot of niceties that we have. So whether you are a Amazon expert or are brand new to the cloud, you can find what you need in the Elastic CI stack for AWS. So we'll run through kind of a high level of what launching the stack looks like, and then we'll take a look at it in action with some of the aforementioned Graviton instances. So from our UI, we have a number of different ways to install our agent, the thing that's going to run our builds and tests for us. And in the AWS side of things, there is just a link that will pop that CloudFormation template open in your AWS account so you can get rocking and rolling. There are a couple of details that will be required. You're going to need a unique stack name as well as your Buildkite agent token because my prod is broken on purpose and has no sensitive information. I'm just throwing that token right into my CloudFormation, but we do have SSM support. So that is the preferred way to get your creds in there. There are a ton of optional tunables. So all of the aforementioned things that we can do in CloudFormation, from setting up our networking to our instances, have some same defaults built into the CloudFormation. If you set nothing here, we'll go ahead and launch a whole new VPC and security groups for you. We'll create an S3 bucket for you to put any secrets into. And if instead, you are an old hat at AWS and already know what your security preferences are, what kind of networks you want to build out, you can optionally replace these with any VPCs, et cetera, that you already have in place. Here is the good news, which is that launching Graviton agents works exactly the same as launching any other Linux instance in AWS. All you need to do is set your instance type to a Graviton instance type, and everything else just works the same as it would on Intel, provided, of course, whatever you're running can run on ARM. So we're going to take a look at this as well as some of the auto-scaling details. There is logic built into this for determining when you do or don't need more agents. It'll actually poll your job queue so that it's got a little bit more intelligent polling than just simple resource allocation. We're also able to set things like the minimum and maximum number of instances we want running in our auto-scaling group. If, say, you're a person that's running demos on a webinar, having a min size of at least one makes a whole lot of sense, so you don't have to wait for that first agent to warm up. As things scale out, you may have a few things run in serial while those machines spin up, but then you'll have the capacity to parallelize whatever's parallelized. You'll also be able to define the idle period, how long those machines are going to sit without a job before they then get reaped and pulled out of the auto-scaling group. So again, this all allows us to optimize for the speed of our builds in sort of whatever throughput we need to do with cost, making sure we're not breaking the bank, keeping up with what we need to do. So with that all said, I am going to take a look at what this looks like in action. So I have launched an auto-scaling group. I have one instance running as mentioned. And I have a project right now that is currently set to use my existing auto-scaling group that was running on Intel instances. So if I go to my pipeline here, the Campfire Rowboat Round is the project we're going to look at here. There's actually a build going on right now. I think I have it building every 10 minutes or so. And if we wanted to look at what's happening on these builds, we can see that they are kicking jobs off to the default agent queue. We have the ability to assign groups of agents to a queue and tag them so that if we wanted to, say, target those ARM instances specifically, we have a way to do so. For right now, the default queue is running this Rycar Buildkite stack, which if I take a look at one of its agents, I can see that it's running Amazon Linux. I can see its IP address, where it's running, etc. It's a T3 large. So this is not one of my Graviton instances. So let's go ahead and change that. I'd like to have this project run on Graviton instead, and it does a lot of stuff in parallel. So it'll be a good opportunity to see whether that auto scaling is indeed working. So I have a copy of my code already checked out. And in the pipeline.yaml here, I'm able to define optionally my agent queue. If I say instead of default, I would like to target Graviton. I'll go ahead and save that and we'll commit our change. Ugh. You can tell I'm freshly fed and caffeinated. I need to go at about half the speed that I've been going. All right, so we have pushed a thing. It does indeed look like there is a build happening. So when the rowboat round starts, my expectation is going to be, hey, look at that. It does look like it's targeting my Graviton instance. So I can come in here, see that it is doing its thing. The rest of my things, even though they could run in parallel, are waiting. It doesn't want to use, even though I have 13 other or 12 other agents going, it wants to make sure that it waits for one to be available inside my Graviton pool. If I go ahead and refresh here, let's see what's going on in AWS. Hey, look at that. So it looks like a few extra machines are being spun up because Buildkite has just requested it to do 10 things at once, and it only has one server to do them on. So it's going ahead and spinning us up some extra capacity. And as it does that, we'll start to be able to see more and more of these working in tandem. Hey, look at that. So as we go down our rowboat round, by the way, did I mention that you can put animated GIFs and emojis into your pipelines? So we can relive the cinematic masterpiece that was Star Trek V and sing row, row, row your boat around a campfire together. And do it in sync now that all of our singers are tuned up and the band is playing. Yeah, you can see I very, very scientific how I skewed these. It does not actually follow in sync as a round, but it's a way to get funny images into my UI here. And it also gives us sort of proof positive of the Elastic Stack doing what we have asked it to do. We can go ahead and confirm now. If we look, our agents are up to 22 here. Got some local ones running on my MacBook. If I want to look at just the Graviton instances, we can see which ones are running, what jobs they're running. And if we click on any individual one, we can see all of the instance metadata about that particular agent's host. When my timeout has been reached, I think in my case, it's like 600 seconds or thereabouts, those machines will start spinning themselves back down until they're down to my minimum of 1. So I'll only be running those when I've got some jobs to do. Although now that I'll be running these a lot more often, I'll probably have a few sitting and warming at any given time. But that is about it on the demo side. So let me go ahead, hop back into Zoom. Feel free to go ahead and shoot us your questions. But let's see here. I think we'll go grab that Elastic CI Stack doc for you. It's like, actually, that's what I meant to show you. I lied. I'm taking the screen share back. The only thing you didn't see here is what it actually looked like to launch that stack. So when you come in here, don't worry, this is my demo environment, security breach. But you can go ahead and get things launched and fill in all of your parameters here. This is where I went and named the queue to Graviton. You can go ahead and grab an edge release if you like to see the latest and greatest stuff. And you can see here, there's a whole bunch of tunables that if you leave blank are just going to go ahead and run some same defaults. But if you want to go run a custom image, run it on whatever instance type you want, you can go ahead and do that. The secrets bucket will also let you set environment variables in such a way that not only do you not need to commit them to your repository, but they will be redacted when they are used within your runs so that they don't show up in the log output in the UI. And that is the demo version of the webinar. So definitely want to open the floor up to your questions. And let's see what we have going on here. How have you found, Arthur, the response has been to the Graviton instances? Definitely seen a lot of folks doing interesting like cost analysis in their environments.
So I would say that if I judge by my daily workload, the adoption has been amazing. It's been really impressive, the amount of customers that have manifested interest and moved workloads. I mean, you know how AWS is working. We release instances in regions depending on customer demand. So initially we released them in a couple of regions in North America, one region in Europe, and one region in APAC. And now it's on almost all of our regions except a couple of regions that we released this year, that we opened this year. So that's a good testimony to how many people have been adopting it. And well, we've been publishing regularly press releases on high-profile company adopting Graviton-based instances. So I'm not going to redo marketing here. There's been enough of that, but yeah, that's been pretty interesting. Another thing maybe that was expected, but that's still a pleasure to see that, is how broad the applicability of those instances have been. So we've seen customers using them everywhere. That was probably a surprise for some people. Initially when we've done the release, people were like, ARM64 on a server, are you serious with that? AWS, what are you doing? Those things, that's good for mobile. And obviously that's not the design that we have done. And so now we do see, well, people using them for web services. That was expected, but they have proven to be super good for databases, for in-memory caches. We have customers using them for high-performance computing. We have customers using them for EDA workloads. Even ARM themselves have disclosed the fact that now they're running a lot of their EDA workload, the electronic design, on top of Graviton-based instances. So all of that is pretty cool.
Yeah, right on. Yeah, I know for my part, it's my favorite thing as a technical marketer, which is a low uplift, high impact thing that you can do. And when it came to like supporting Graviton, like, I mean, it's a matter of making sure that we have a ARM64 compatible binary. But beyond that, it's pretty much just like I went to the getting started guide and I substituted the T3 for an M4G and it just worked. And like, yes, sure, no news is indeed good news in this case. I just do the thing that I could already do.
And that's really a good call. The goal on our side is really to make the transition as transparent and as smooth as possible. Of course, the microarchitecture is different, but unless you're really doing low-level stuff, from an application standpoint and even from a development standpoint, chances are that you will barely notice. What you will notice is that it's going to be cheaper and faster. But from a pure technical standpoint, unless you're writing assembly or calling intrinsics or things of that nature, that should be as transparent as possible. And that's definitely the experience of, I don't know, probably somewhere between 90 and 95% of our customers. And thanks to ISVs like you guys, the gap is being closed more and more with regards to coverage. We still have, of course, partners that have not yet released for Graviton, but more and more are doing it on an almost daily basis. And so chances are that whatever your application is, it could run on Graviton. I mean, unless you're running Windows Server, which is not yet there. If you're relying on Linux or FreeBSD or NetBSD, that should run on Graviton.
Yeah. Well, and that's the other thing too, is like even above and beyond sort of like, folks learning for the first time, like, this is really good for my kind of workload. Even going back to that, like, well, that's for mobile phones. Well, doing CI for mobile phones in environments that work mostly like mobile phones that are doing ARM emulation on Intel, you're always going to end up with those "it worked on my box" edge cases. So like being able to work natively in ARM just helps give support to a whole different developer community that is had to make do with close enough.
And that's definitely a good opportunity. Like all the workloads that have some kind of already a connection to the ARM64 architecture. So whether you're developing for mobile or developing for embedded, so mobile is a good use case. And there are a couple of companies that are offering tools to do Q&A on top of ARM64 after you've built your stuff. So that's a good opportunity. We've seen also automotive vendors because there's ARM64 chips in the cars, and now they get the opportunity to build natively and no longer rely on cross compilers. And better than that, doing the Q&A on top of Graviton instances, because basically the architecture is the same as the one in the cars. And instead of having to build and then upload to specific devices and maintain farms of devices, they can run directly at scale in the cloud. And the things that they would be able to run on only a couple development boards, they can now do that on hundreds of instances at the same time. So it offers new possibilities in terms of testing systematically, that kind of stuff that was just not possible before.
Right on. Let's see here. Doesn't look like any more questions have come in. We'll give folks another moment, but if this ends up being where we call it, we will be back at the top of the hour with another AWS session. We'll be taking a look at the EC2 Mac instances and the Elastic CI Stack solution for them, which is a little bit different.
I have a question.
Yeah, go for it.
So there's a question from Andrew asking whether Graviton is available as spot instances. The answer is yes. Graviton-based instances are available with all our selling model. So you can use them as spot instances. You can use saving plans. You can use RIs, and of course, on demand. But that's exactly the same as all the rest of our portfolio. And actually, there's no reason why we should make them different. The depth of the pool might vary, depend on the instance type, and that's not necessarily tied to being Graviton or not Graviton. Usually new instances would have spot pools that are less deep than the older ones. But they're all available as spot instances there.
Yeah, excellent. And I suppose worth noting as well that the Elastic CI Stack, one of the tunable parameters in there is the on-demand percentage. So if you want to make use of your spot instances as your build agents, you certainly can. I think there is also, you can set your maximum spot price in your CloudFormation as well.
And using spot instances for CI is definitely a thing that I would recommend doing. Most of the time, you can support a build to be interrupted. Well, if you lose the instance that is doing the build, it's not a big deal. That's another build job that you will restart. Potentially a series of tests or a build will be lost, but the savings that you will be doing by using spot instead of on demand will more than compensate for that. So unless you really have super hard deadlines with your builds and you want to ensure that you're not losing any second, definitely use Spot.
Right on. And that is the wonder of it, is you got bursty behavior, but you can at least predict some baseline, and that's the part you can get some good cost savings on. Oh, we've got a comment. Folks have started using Graviton via Elastic CI to target M1 Macs, producing internal tools. Much easier for the producing teams who are not involved with the Mac intra generally. That's
nice.
cool. Yeah. Yeah, that hadn't occurred to me, but that makes total sense.
I must admit that it's the first time that I see that. I'm a little bit curious here. Are you using it and generating Mac-O binaries from Linux instances running on Graviton?
Yeah. It's like, would you like to come give a talk at UnblockConf21? Right on. Any info on what to expect from Graviton 3?
I don't know what Graviton 3 is.
Well,
have you ever heard about that? Well, my best recommendation is ReInvent is in 2 weeks from now. Usually AWS do make announcement at ReInvent. So yeah, stay tuned.
There's another thing that you're doing in November? Indeed. And actually, that is a fantastic segue. Anything that you have to promote, sir? Yeah, I understand that there's this ReInvent, you said it was called?
Yeah, that's a weird conference where, well, a big cloud vendor is doing some announcement and talking about many of the things that we are doing. If any of you is attending, I will be leading a workshop on Graviton. So that's going to be an opportunity to get hands-on, doing a couple containers related hands-on labs on top of Graviton. We have a performance lab also where you will learn how to benchmark a web application, that kind of stuff, and analyze the behavior. There's also a couple of sessions on ReInvent. I'm leading one on how to run container-based workload on top of Graviton. There's a session where we will have customers talking about the applications that they have ported to Graviton. There will be sessions also on the custom silicon design that we are doing, led by Ali Saidi, one of our senior principal engineers. So yeah, plenty of content. And if you're not attending, many of those sessions are recorded and they will be broadcasted the week of ReInvent and published to either the conference website or later on YouTube. So you will be able to watch them whenever convenient for you guys if you're not comfortable coming to Vegas. I hate Vegas, by the way, but yeah, still, I like going there and meeting customers.
Right on. Yeah, no, looking forward to all the announcements soon to come. And we had a follow-up on the previous use case. The use case was producing multi-architecture Docker images that could run on M1 Macs.
Oh, nice.
Excellent.
Okay.
Very nice. Okay. So yeah, I think with that, we'll go ahead and close out the session. We'll see you again at the top of the hour. Arthur, thank you so much for joining us.
Nick, thank you so much for inviting me. And yeah, good luck and happy to see your product supporting the Graviton-based instances. That's awesome.
Right on. Well, take care, everybody.
See you guys.